Assalamualaikum and hi, my name is Shafiq Rosman with matrix number AA200003, and I am the first representative from my group, which is group 2 from section 7. So we will be presenting our group project for this subject, which is mechanic of machine with code DAM23803. So here is the table of content for our project, starting with introduction, background of case study, basic theory or literature review, analysis and calculation, discussion, and the last one is conclusion.
Assalamualaikum. Hi, my name is Muhammad Azmi Yunus. My number matric is AA2005. So I will tell about the introduction. Exercise is one of the most popular activities among people from all walks of life, regardless of when or where they do it. Exercise activities have been the activities of choice for everyone since time immemorial, since they are simple to adopt and do not involve the acquisition of expensive exercise equipment. People used to have to cycle outside to exercise, and they had to cope with various types of weather, which interrupt their exercise performance to some level. There are now exercise bikes that allow individuals to exercise whenever they want and without having to worry about the weather, which is the main reason why people do not exercise. This modern development demonstrates that equipment provides a variety of benefits to society in terms of a healthy lifestyle and sharp intellect.
Hello, my name is Muhammad Izzuddin Mizami. Now I will talk about background of case study in this report. First, chain stationary bike and bed drive stationary bike are two types of stationary bike. So in the case, we explain bed drive stationary bike. In the operation of a stationary bike, there are two titles in mechanic of machine. First, the open bed in the power transfer title, and the screw on resistance knob in the friction and wear title. Bed driven bikes require far less maintenance than chain driver cycles. They also provide a smoother and quieter ride, which is preferred by many studio and residents. Furthermore, with time, the bed can wear down and stretch. Necessitating is replacement. Keeps in mind that getting to that stage necessary of significant quantity of usage. Friction resistance was once the gold standard for stationary bike resistance. To compare how this type of model works, we must first comprehend friction. This pad can be found on each side of the flywheel and squeeze the flywheel. When the resistance knob is pushed to the right, or they can be combined into one larger pad that exerts downward pressure on the spinning flywheel. Fabric is commonly used to make the parts. That's all. Okay, now I will talk about basic theory or literature review. First, velocity ratio. N2 over N1. That means driven velocity over driver velocity equal to W. W for angular velocity. W2 over W1 equal to N. N for speed or RPM. N2 over N1 equal to D1 over D2. D, that means diameter of the gear, equal to D1 plus T, and D2 plus T. How to get N2 over N1 is W2 pi N, and D1 for D2, this formula for W equal V over R equal 2V over D. For angle of contact, sin alpha equal D1 minus D2 over X, and tension ratio in a bed drive, T1, that means tension of the tight side of the bed, over T2, tension on the slack side of the bed, equal E in the power, coefficient and theta. For power transmitter for flatbed is P equal T1 minus T2 and multiply V. That's all. Okay, next basic theory and literature review for screw resistant or not in the title friction and wear. First, limiting angle. Tan limiting angle equal to efficiency screw angle. Tan screw angle equal P for pitch over pi d diameter. Force P, that means P equal to W multiply in tan screw angle cos beta plus tan alpha over cos beta minus tan screw angle and tan limiting angle. P for force, W for weight. Torque T equal to P multiply D over 2. Efficiency equal to tan alpha plus screw angle over screw angle, tan screw angle. That's all from me. Thank you.
The next part is the part of analysis and calculation. So based on our case, which is about the stationary bike, so the chapters involved for this stationary bike is first is the power transfer, and the second one is the friction and wear.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rukman Rakim Bazul and my matrix number is AA200054. So I will continue the presentation with the calculation and analysis. So first we use an open flat belt drive for this stationary bike. So the belt is connected by two parallel shafts which is 1.2 meter apart. So the driving shaft rotates at 350 rpm and the driven shaft rotates at 140 rpm for an average cycling speed. So we also know that the diameter for the driven pulley is 500 mm and the belt is 5 mm thick and 80 mm wide. So the coefficient between the belt and the pulley is 0.3 and the maximum permissible tension we assume it is 1.4 meganewton per meter square. So based on the given information, so we can calculate the needed question, which is number 1, the diameter of the driving pulley, number 2, the maximum power that may be transmitted by the belting, and number 3, the initial belt tension. So for question 1, the diameter for the driving pulley, we know that using the ratio N2 over N1 equals to D1 over D2, we can simply get the D1, which is N2 times D2 over N1. So we get 0.16 meter. So for question 2, we need to find the maximum power that may be transmitted by the belting. So we basically using formula P equals to T1 minus T2 times V. So V is the velocity. So first we need to find the T1 and T2. So T1 we assume it is the tight side, the tension of the tight side of the belt, and T2 is the slack side tension of the belt. So T1 we can get by using the formula permissible tension times B and times T, we get 560 Newton, and T2 using the formula T1 over coefficient of friction times theta that we get above, which is 168.52, so we get 2.42. So T2 equals to 231.4 Newton. So the velocity of the belt, we use the formula pi D1 times N1 over 60, we get 2.93 meter per second. So for lastly, we get the power that may be transmitted, which is P equals to T1 minus T2 times V, which is 963 watt. So for question 3, we need to find the required initial belt tension. So we use the formula T equals to T1 times. For question 3, required initial belt tension. So we know that the initial belt tension using formula T equals to T1 plus T2 over 2. So T1 we get before is 560 and T2 is 251.4 Newton over 2. So for the initial belt tension is 395.7 Newton.
Assalamualaikum and hi, my name is Shafiqul bin Ruzman with matrix number AA200023. And next I will be covering the second part, which is I will be explaining about the chapters that involve in this gym equipment, which is the stationary bike. So the next chapter that involved is the chapter 4, which is the friction and wear. So for this stationary bike, the compartment that involved is the resistant knob. So basically a resistant knob is a device that is used together with a brake pad that will touch and hold the flywheel of the bike's working mechanism by lowering or raise the brake pad in order to vary the resistance. So for example, when the brake pad touches the flywheel so hard, therefore the resistance will be higher. So next, based on the mechanism of the resistor knob, this device actually use a long V track rod to linearly move up or down the brake pad for changing the level of resistance. So this is the picture of the resistor knob. So given the V thread is or beta is equal to 10 degree, a threaded screw has mean diameter of 6 mm and the pitch is 3 mm. Given that the coefficient of friction between the nut and the screw is 0.25, and we assume that the load to rotate is with the thread. So based on this data, the information that can be obtained is that we can determine the torque required to lower a load of 5 kN, or in other words, by twisting in clockwise direction, so that we can lower the resistance knob along with the brake pad itself. And the next question, based on this data, you can also find the percentage efficiency. So the calculation for this question is first, basically we need to find the limiting angle or alpha. So based on the formula, which is the tan alpha equal to mu or coefficient of friction, which is given. So therefore we can solve it and we can find the limiting angle, which is equal to 14.04 degree. After we find the limiting angle, we need to find the screw angle or theta. So also using the formula given, which is time theta equal to pitch divided by pi times diameter. So using all the information that we have, we can find the screw angle, which is we got 9.04 degree. And once we have all the information, the limiting angle and the screw angle, we have to know that this question we need to find the torque, which is the formula of torque is torque equal to P or force times by diameter divided by 2. So therefore we need to find the force or P first. So the formula of force is P equal to W or weight times by tan alpha minus tan theta times by cos beta divided by cos beta plus tan theta times tan alpha. So this formula is used because in this case the screw is needed to lower the load So therefore this formula is required to be used. So therefore by substituting all the information that we can have the value of force, or P, which is equal to 455.72 Newton. And lastly, we can find the torque needed, which is P times by D divided by 2. So therefore, the torque needed to lower a load of 5 kN is 1.37 Newton meter. And for the next question, where we need to find the percentage of efficiency. So by using the formula, remember for this scenario, the scenario is about to lower a load. So therefore the formula that need to be used is N equal to tan alpha plus theta divided by tan theta. So using all of information that we have, therefore the percentage of efficiency is equal to 0.373 or 37.3% of efficiency.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Mashul Bakirus. My ticket number is 88200798. Now I will explain about discussion about this project. So for the first part, based on the situation where the open flat belt in the stationary bike, two parallel shaft 1.2 meter apart link the belt. For an average cycle speed, the driving shaft rotates at 350 rpm, while the driver shaft rotates at 140 rpm. We also know that the driving pulley has a diameter of 400 mm. The belt is 80 mm wide and 5 mm thick. And we consider the belt pulley coefficient is 0.3, and the maximum permitted tension in the belt is 4.1 meganewton per meter square. First, we can determine the diameter of the driving pulley by using the stated formula and given information where the driving shaft rotate, which is N1 equal to 350, and the drive shaft rotate, which is N2 equals to 140 rpm. Also, we got D2 is 0.4 meter. Therefore, the diameter of the driving pulley we got is 0.16 meter. So the second question or second problem is to calculate the maximum power that may be transmitted by the belting. The first step is to calculate the T1 and T2, which are the tension in the tight and slack side of the belt. After we use the stated formula, we got the value of T1 and T2, 560 Newton and 231.4 Newton respectively. And after that, we can the belt's velocity is thus calculated to be 2.93 meter per second. So we can compute that the power transfer when we have all of the above data, which is 963 watt or 0.963 kilowatt. And the final question or the final problem is of the stationary bike in belting is determining the requiring initial belt tension. So for this question, we can directly utilize the provided formula to determine the value, which is 395.7 Newton for this situation. And that is the end of the first part of the question. So for the next part, for this problem, for this project is the resistance knob in stationary bike. So the information given is a threaded screw with a V thread of omega equals to 10 as a mean diameter, of 6 millimeter and the pitch of 3 millimeter. Also is given a coefficient of friction which is 0.25 between the nut and screw. Assuming the load rotates together with the thread. So the first information is to determine the torque required on the screw to raise the load, which is the load equals to 5 kilonewton. So the first step is to calculate the limiting angle and the screw angle, which we got 14.04 degree and 9.04 degree respectively. And then we use the static method or static formula to determine the force, which is P, and we get 55.775 Newton. And finally, using all the data we calculate before, we estimate the torque, which is we got 1.37 Newton meter. And that's how we solve the problem. Or the last problem is to calculate the percentage efficiency. So for this question, we simply use the equation and use all the information that we calculate before, and we use back, and we got the zero, and we obtain the percentage efficiency is 37.3%. And that's the end of the discussion part. Thank you very much.
After finishing this report, we have recognized two ideas that we have learned, namely power transfer and friction and wear, that are applied in a workout device today, namely the stationary cycle. Finally, we run some calculations to see how these two notions interact to create modern exercise equipment that allow individuals to exercise without exerting too much effort simply by being indoors. As a result, it can save money, time, and reduce accident risk. That's all from me. Thank you.
And that is all from us, Group 2 from Section 7. Thank you and Assalamualaikum.